So concentrating on an equation given 2 points. So taking out the words completely. We're going to take out the words completely. And what if I'm giving two statements of relationships where I start and end with a number and then I start and end with another group of numbers? So we're going to set up some tables today. Let's recall that whenever we write an equation of a line, this is a model. And we're going to start and end with two relationships. So start with 3, end with -3. Start with -3, end with 1. Yesterday we had some sort of rate times the x column plus a magic number. But now we're not given the rate. We've got to figure it out. And that rate is going to be the change in the y column divided by the change in the x column. So the jump from the first y to the second y is a +4. The jump from the first y to the second y. So now we're going to take this rate or slope is going to be the change in the y column divided by the change in the x column. So I'm actually going to do a little erasing. We just found the rate, or what some of you know as slope. 4 divided by -6. So let's make sure every single time that we put the change in the y column divided by the change in the x column. That's going to be our rate. So we're going to take 4 divided by -6 times 3, and then we'll figure out, well, how much more do we need to add to get to -3? We're going to do it again to see, okay, 4 divided by -6 times -3 plus a magic number to get to this end. So after this reducing, -2/3 times 3 plus what gets me to -3? If I do it again, -2/3 times -3 plus what gets me to 1? So I'm going to repeat that one more time. -2/3 times 3 leaves us with -2 plus -1 gets me to -3. We're going to test it out again here. If you take -2/3 times 3 or times -3, we're left with a +2. And if you want to write that down below, that's okay. +2 plus what gets us to -1? We're back to that -1 idea. Let's talk about writing a model. If we wrote a model, it's going to be y equals whatever our rate is times x plus this special number. So the model transforms into, well, we could either say y equals, or the rate, which was -2/3, we reduced. So -2/3 times x column -1 or plus -1 is also acceptable, equaled the y column. This is acceptable. Also, if you flipped it around, y equals -2/3 x minus 1. Again, let's actually box writing an equation. Write an equation means model. Write a model. And we're going to go through these given points. You've got your starting numbers. So we start with 7s, end with 3. Start with 2, end with, start with 2, end with 2. So within our table, we always start with the first number. We're going to take a rate times that number and try to figure out this magic ending. And we'll end with the other number that was paired up. So start with a 7, we're supposed to end with a 3. Start with a 2, we're supposed to end with a 2. What's the change in the y's? You see it. What's the change in the x's? So change in the change in the y divided by change in the x, +1/5. Gross! And then we've got to figure out, wait a second, how much more should we be adding on in order to get to another whole number? So let's do a little thought. A fifth times 7, if you put 7 over 1, that would be 7/5. Sometimes fractions aren't as bad as what we think. 7/5. Let's turn that into a mixed number. There's a whole in there, and then 2 left over. Let's deal with the fractions first. How many more do we need in order to get to the next whole dealing with just 2/5? Part of this number is 3/5. So if you have a whole and another whole combined, we need one more whole to get to 3. This is our magic number, 1 3/5. We could either write it like a mixed number or put it into improper, which would be 8/5. If you don't remember how to get that into a mixed number, 5 times 1, add 3. So 8/5 could also be used as our magic number. Might need a little calculator work to test this 8/5 theory. So a fifth times 2 is 2/5 plus 1 3/5. It does get us to 2 wholes. So let's talk about this model. We're writing an equation, which is a model. So 1/5 x plus 8/5 equals the y column. This is where I want us to be. If we self-start, this is where I want you to immediately put down already on example 4. So even though we're on example 3, this should still be the setup for example 4, just with those numbers. We're going to find the difference in the y's compared to the difference in the x's. And we're going to divide the change in the y's divided by the change in the x's. So if you take -2 divided by a +2, we're at a -1. I had a good question and I want to address it. So what about the second, like, do we need that second guy? And I do want to stress the second one confirms sort of like what becomes the variable, what doesn't. We found that 8 was the magic number. On Monday we had a big old table and we said, hey, what stayed the same? And -1 stayed the same in both portions, or I should say in both rows. But then we had a varying number and it gets a variable. The 3 and the 5 came from the x's. So we have -1x. The +8 stays in both rows. So that's solidified. And it equals the varying numbers again, coming from the y column. So writing the model is more helpful when we have 2 rows. It's what is solidified, that stays. What varies gets a variable. Let's go to the next one. Setup stays the same. Hopefully we've made it this far. Okay. So the rate is a 1/9. If you take a 1/9 times -8, you're at -8/9. So how much do you have to add to get to 2 wholes? So if you're at -8/9, you have to add 8/9 to get to 0, and then you have to have 2 more wholes. So in the second row, a 1/9 times 1, we still have to add 2 wholes and 8 more 9ths to get to 3. So let's talk about this model. What stayed the same was a 1/9 times the x column plus 2 and 8/9, and that equaled the y column.